We go see this audio guy. What do you think? You want to go see him about what he's got?
I definitely want to see this equipment.
Okay.
Yeah.
Yeah, he says
interesting.
that you can audio map even underwater an entire space, and if something goes through it, that you'll see it. That it's like the Matrix or something. You see it in.
So even if something isn't completely solid, you still might see some kind of form.
That's right.
That could be very useful.
Let's check it out.
All right. We are here with Jake Hoffman, acoustician, audio engineer. Cool.
Yeah, I am a cool guy.
And he's going to show us some new audio equipment that may be applicable to our ghost hunting expeditions. We're hoping.
So I'll show you what I have in mind here. Let me just go through. So we have a microphone. There's a measurement microphone. The phantom power is turned on. So these are just different kinds of measurement microphones. This is a source we can use pink noise or white noise from this source right here. This is a calibrator to calibrate exact levels of microphones. This is a completely another thing that we could possibly use. This is an accelerometer, and it's DC. It's a current source. So where that has value is it can measure things that are way below audible, or even potentially things way above audible.
And you said this is a measurement microphone?
This is a measurement mic. It's very, very accurate from very low frequencies to very high frequencies. And what we can do to calibrate it, so we make sure that from one situation to another, we're very accurate. We have a calibration device here to calibrate this thing to about 1/10 of a dB. And the reason it's important is if you wanted to do something that's repeatable. So you're coming back at another day and you want to verify that something is exactly at the same level, the noise or whatever it may be. If you don't have some method of calibrating it, how do you know where, it could be, you could be significantly off. So these things are important if you're wanting anything that is repeatable. There's a variety of ways to look at this. So as an example, here's something called 24th. This is 24th octave band right here. You're seeing 20 hertz to 20,000 hertz right here.
Wow.
Okay. Now we can actually go much lower. You can start seeing.
Whoa.
You can see that we're actually seeing things down to here's 1 hertz.
Get out.
Right here.
So what would be accounting for the movement there? Like what's
because the world makes noise. Right?
So when they're talking about room tone, you're being quite literal.
The reason the spectrograph has a lot of value is it is basically just another representation of this right here.
Right.
Okay, the difference is that you can now set this up so you can set different thresholds. And the reason is visually, you can now see that there's a tremendous constant band of energy from 20 to 50, and so what can happen is you can very, very easily see when something is changing, right? And in what frequency band that energy's in.
And so this shows up as blue to yellow when it's played?
So if we were running pink noise into there and capturing it on the mic,
Right through a speaker,
and there was some anomaly in the room that occurred, we would be able to see it.
Yeah, if something was affecting those waves that were propagating and hitting all of these surfaces, right? If there was something that was causing that to be modified in some way, you would see that, right?
Spirits from another world would qualify as
Yeah.
interruption to audio source.
They're not exactly a hard surface, but it's a possibility.
It's a possibility, right?
Well, we'd have to test it.
Now, do you have any experience with using this kind of equipment underwater?
Yeah, how would we use it?
How does that change the acoustically?
Well, there's no reason you couldn't use this equipment. You couldn't put the computer underwater, obviously.
Right.
Yeah.
But there's no reason what would have to happen is, the only differences would be, the microphone would have to be a hydrophone. It would have to be designed to go underwater.
Hydrophone.
Which there's microphones.
Special design piece of equipment.
There's
Alright,
there's
fine.
microphones that are designed for that.
Okay.
And the accelerometers, that's not a problem. These devices can go. It's a completely sealed device. This can go underwater.
With it, you could kind of like create a space. You could create like a cubic environment.
In other words, what would be interesting, exactly. In other words, what you could do with that, let's say you had 8 accelerometers across an area, right? What that would you could then start identifying if some noise were to occur, you could actually start identifying where in space it was, right?
If it's moving, you can track it.
Right, you would see it moving across which accelerometers it was affecting.
Whoa.
Right?
That's good stuff.
Right.
Dude,
Yeah.
awesome stuff, man.
So that's what this does.
Thank you.
Yeah.
So, Che, It was great to meet you. I think
Yeah,
you
good
can
to
become
meet
the Q of the
Yeah, big
paranormal
time.
divers.
Big time.